Hello everybody. This lecture is about Moore to Mealy conversion. Moore to Mealy conversion. And vice versa. Okay, so we will be looking at how to convert a Moore machine into a Mealy machine and so on and so forth. Okay, so first of all, we are just revising what is a Moore machine, what is a Mealy machine. When we talk about Moore machine, it means that it has only one output is only dependent on the initial state. So let me give you a very basic example of a Moore machine. Let me just draw it. So we've got Q naught. So for that we have more hardware as GPU, and we need to purchase the GPU. To reduce the high processing time, so these are the outputs. So either we have to fill the time or either we have to lose our time. So these are the certain disadvantages of KMI. Time is there. So in the next class, we will start with the introduction to biological neurons. Very practical manner. Okay, guys? Okay. So now I have created this Moore machine. This is a Moore machine. I hope everybody is clear about what is a Moore machine, what is a Mealy machine. This is a Moore machine. Now, if I have to convert this thing into a Mealy machine, the basic idea of a Mealy machine or Moore machine is, when we are converting Moore to Mealy, is that the delta of Q naught on A is what? The delta of Q naught on A. This is what we have to find out. Okay. I'm sorry, it is lambda. Okay. So we are just calling it lambda, lambda dash, whatever you want to call it, lambda. It actually means lambda of delta of Q naught of A. So this left hand side is the output function of your Mealy machine. Okay, this is the output function of your Mealy machine, lambda dash. Lambda dash of Q naught on A will give me something which is lambda of delta of Q naught A. That's the very basic idea. So it becomes what? Delta of Q naught A is Q naught on A goes to Q1, right? So it becomes lambda of Q1. Now what is lambda of Q1? Lambda of Q1 is 0. Okay, so it is Q naught A when Q naught on A goes to Q1. What is the output associated with Q1? It is 0. That's the output for Q naught on A when it considered for lambda dash of the Mealy machine. Okay. Similarly, lambda dash on Q naught B will be lambda of delta of Q naught B of the Moore machine. So lambda of Q naught B is what? Q naught B is Q naught on B is Q naught only. So it is Q naught. Lambda of Q naught is what? 0. 0 is associated with Q naught. So 0. Got it? Similarly, we can create everything. I'll just write it down. Lambda dash of Q1A, lambda dash of Q1B, lambda dash of Q2A, and lambda dash of Q2 on B is, I'll just write it down. I already have the answers. 0, 1, and 0, 0. So you please try to find out this answer, and this is easier. Okay, this is much easier to do. So now you have got the outputs and everything. Now we just create the transition table for the Mealy machine. So how do we create the transition table? Now we have to create the delta of the Mealy machine. Okay, so how the delta of the Mealy machine is created? So you've got Q here, Q naught, Q1, Q2. Okay. And there you have add the input A and add the input B. What is the next state? What is the next state and what is the output? Similarly, here also, what is the next state and what is the output? So next state, you don't have to worry about the next state because delta dash, I'll just keep it delta dash of Q naught on A will be equal to delta of Q naught on A only. Okay. The transition function remains the same, just that the output function gets changed, or you can say the values of the output get changed. Okay, so you've got Q naught with A, Q naught is Q1, Q1 on is A is Q1, and Q2 on A is also Q1. Delta becomes 0, 0, 0. Essentially, you just have to look at this Q1. Q1 is always associated with 0. That's why it is always with Q1, 0. Now, Q naught on B is what? Q naught on B is at Q naught. And Q naught is associated with 0. Q1 on B is what? Q1 on B is Q2. And Q2 is associated with 1. So here is Q2 and 1. Okay. Similarly, Q naught, 0. So this becomes your Mealy machine. Okay. You can create the diagram on your own. I don't have to explain that to you. Or chalo, let's just create this. Let's create this. So we've got Q naught B/0 Q1 Q2 A/0 B/1, and here we have A/0 B/0. So this is your Mealy machine. Now, how do you convert a Mealy to Moore? Now, converting Moore to Mealy is a very straight affair. There is not a difference. There is just the difference in the delta. There is no change in number of states. There is no change in the transition function. Only the change, or you can say the transformation happens in the lambda, which is the output function. But when we're talking about Mealy machine will give us different number of states also. In fact, you might get an increased number of state when we are converting from Mealy machine to Moore machine. Okay, one thing that you have to keep in mind is that you will get increased number of states as per the outputs. I'll tell you just what it is. So I'll just take an example, a very simple example. Q1 Q2 Q3 0/0 1/0 1/1 and 0/1. Next is 1/0 and 0/0. So this is your an example of a Mealy machine. We know that Q1 and so now the most important aspect is to first create the table. For Mealy machine, it is important to create a table. In Moore also you should create it, but I mean in the previous conversion it was not important because it was easier to understand it. So you got Q on 0, 0 and 1. So you've got the Q and the delta, and here also Q and the delta. Okay, so you've got Q1, Q2 and Q3. Okay, Q1 on 0 is goes back to Q1 1 and output is 0. Q1 on 1 goes to Q2, output is 1. Q2 on 0 goes to Q2, output is 1. Q2 on 1 goes to Q3, output is 0. Q3 goes to Q2 on 0 and output is 0. And Q3 on 1 goes to Q3 and output is 1. Okay, I hope this is clear to you. Now please look at the important aspect, that is there any state which is mapped to or which has different outputs. Just now look here in this right hand side. Look here in this right hand side here. Is there any combination which includes different states and different outputs? Oh, sorry, same state but different outputs. Same states but different outputs. For example, we've got Q1. So we've got Q1 0 and anywhere else Q1? No. So Q1 is only mapped to 0. Then we have Q2. Q2 is mapped to 0 as well as Q2 is mapped to 1. And you can see 1 here and 0 here. Similarly, Q3, I'll just write it here. Q3 is mapped to 0 as well as Q3 is mapped to 1, as you can see here, and here. Yes or no? So I hope this is clear. So when we are talking about conversion of Mealy to Moore, now we split these states. Now the new states for the Mealy machine will become, the new states for Mealy machine will become Q1, Q20, Q21, Q30, Q31. So why are we saying Q20, Q21? Because this is the state of Q2, which is also going to 0, also going to 1. So with the state which is going to 0, we call it Q20. The state which is with whose output is 0 or whose output is 1, we're calling it Q21. Similarly, this thing means Q3 with the output 0. Here Q3 with the output 1. Okay, so we've got, I hope this is clear, we've got 5 states as compared to the 3 states earlier which we had in the Mealy machine. Okay, so now what do we have to do is, now the idea is to just create the transition table for the Mealy machine. It's now it becomes very simple. The only idea is to split up. Now it becomes very simple. So we'll pick up the state. We'll have this thing next state on 0 and next state on 1 and the delta. Sorry. And the delta. So Q is Q1, Q2 0, Q2 1, Q3 0 and Q3 1. Okay, ji. So Q1 on 0, Q1 on 0, Q1 on 0 is Q1, Q2, Q1 on 0 is Q1, and Q1 on 1 is Q2, and delta is what? Output is what? Here, just check out this thing. Is Q2 0 or Q2 1? Okay, first of all, just check. Q1 is associated with which output? 0. So here it is 0, right? Since in here it is 0, we will have this thing here. Okay. Now Q2 goes to what? This is Q2 0. Just a second. Am I making a mistake? Just a second. I might have made a mistake. Here we have Q2 0 only. Yeah, it is a 0 only. That's why I was just getting confused. It is a 0 because you see Q1 1 and 0. So Q1 on Q2 goes to 0. That's why it is here. It is Q2 0. It's not because here it is 0. Okay. Let me rephrase it again. I just wanted to clarify. This is a 0 here. Okay. And now let's just erase this first. So we know we have to just create the basic transition table for the transition and the output function table for the Mealy machine. Now we can see transition table. Transition for Q1 on 0 is Q1, which we know. Q1 on 0 is Q1. Cool. Now Q1 on uh, Q1 on 1 is Q2. But which output? Q2 is associated with which output? 0. So this will become Q2 0. So that's why this will become Q2 0. And the output associated with Q1 is 0. The output associated with Q1 is 0. Okay, so this is what it is. Similarly, Q2 0. Now we look at Q2. So Q2 on 0 goes to Q2, but output is 1. So here the state will become Q2 1. Okay, because this one is associated with Q2 1. Okay, next is on 1 Q2 goes to Q3 0. Q3 0. Why? Because here it is 0 and here is 3. So Q3 0. But here 0. So 0. Now I'll just use another color. No? So this 0 is associated with this 0. Okay, so don't get confused. Similarly, when we are talking about Q2 1, the transition will be the same, Q2 1 and Q3 0. But the output will become 1 because this one is associated with this output. Okay, so I'll just write the other one. Q3 will be Q2 0 and Q3 1. Q2 0 and Q3 1, and the output will be 0. Q2 0 and Q3 1, and output will be 1. Okay, so that's how we create the Mealy machine. Okay, now this is a Mealy machine. Okay, so Mealy machine has more states. The only idea about Mealy machine is to split the states, split them up. Okay, if you don't split every state, if any state is going to multiple outputs or has multiple outputs, then you say that then we will split those states, else we don't need to split those states. Okay. So I'll just revise once more. So in Mealy to Mealy, that there is nothing to do. The only idea about Mealy, Mealy to Mealy is the output function, which is the lambda dash. Lambda dash is equal to lambda of delta of Q naught A, and then you can calculate all of the lambda for this thing. This is also okay. If you create the Mealy machines transition table and then you create all these things, then it's also okay. Okay. Then you have delta dash with Mealy. This is the output of this thing. Okay. Next was the transition graph for the same, and you have Mealy to Mealy. Now this is Mealy to Mealy. This is first the transition graph of the Mealy machine, which we have already seen. This transition graph is then converted into the Mealy machine's transition graph. Now you want to create the graph. Let's just look at this in just another 2 minutes. So we will get Q1 is associated with which output? 0, always. So Q1 will always be associated with 0 output. So it is clear. So Q1 on 0 goes to which one? Q1 on 0 goes to Q1 only, and on 1 goes to Q2 0. So on 0 it goes back to this one only. On 1 it goes to Q2 0, and Q2 0 output is 0. Q2 0 on 0, Q2 1 1, Q2 1 on 0 goes back to itself, and then we have Q3 0 slash 0 and Q3 1 slash 1. So this will be our state. So on 1 it goes to this state, and on and on this thing 0, this is 1, and the last two remaining states is this 1, and this goes to 0 and another a self loop of 1. Okay, it doesn't look that great, but I hope that that explains it to you. So yeah, so I hope this is clear to everyone, and we'll catch up in the next lecture. Thank you so much for the Murray and Mealy conversion and